What is an operating system? Every computer is made up of some hardware, right? You have the CPU, memory, storage, you have input and output devices such as screen, mouse, keyboard, and all the programs running on your computer need to use these hardware resources. So how do you interact with these hardware components as a computer user? For example, if you want to use a software application like Google Chrome browser on your computer, it will need to access the CPU and memory to process the data. You will want to interact with it with mouse and keyboard and display it on the screen. So how does browser application know how to take mouse and keyboard input, display information on the screen, or allocate CPU and memory to do its job? Well, it doesn't. The applications themselves do not actually know how to use hardware components and how to interact with them. You can't install Chrome directly on a hardware, because if you did, then the browser application must have the code that can talk to each and every hardware part. In the same way, every other application running on your computer will have to include some kind of code to talk to all hardware components. And that will be extremely inefficient because then every programmer for every application would need to implement all of this. So instead, these applications can all use an intermediary to talk to the hardware. And that intermediary is the computer's operating system. Operating system can interact with and control the hardware as well as interact with the applications. So it's kind of the middleman between the two. So Chrome application will request memory to save some temporary data by asking the operating system, hey, can you get me some memory from hardware? Or when you click the icon to start the application, operating system will interpret your mouse click and tell the browser application to start. Again, allocating resources like CPU and memory to it. So it's a translator between the applications that run on your computer and the hardware that your computer is made up of. Also, operating system will manage the fair usage of resources among the applications. So for example, if Chrome is using a lot of resources or too many resources, but it hasn't been active for a while, and user opens Safari, then operating system will take away the resources from Chrome and give those resources to Safari. So it has an intelligent logic to decide which application gets how many resources. And also it isolates the contents of different applications so that they don't interfere with each other's resources. Now let's see a bit closer what are the tasks of an operating system. And this can be grouped into several categories. First of all, operating system is responsible for allocating and managing the hardware resources like CPU, memory, storage, and input-output devices. So the first one is process management. That's managing the CPU resources. This is an example of activity monitor on a macOS that shows different processes running on a computer. You have the ScreenFlow recorder, multiple Google Chrome resources, and so on. And each has its share of CPU allocated to it. Now, what is a process? Process is a small unit that executes on a computer. New browser tab, for example, is a process. Starting IntelliJ is a process. Or opening a new terminal window is a process. Each process has its own isolated space to execute so that they won't interfere with execution of each other. This makes sure things don't break, but also that processes are protected. Note that if a computer has one CPU, it can process only one process at a time. So you may be doing many things at the same time, like listening to music, browsing web, writing a document, working in your terminal, but one CPU in the background is processing only one task at each time. The CPU is just switching content so fast that you have an illusion of parallel or multitask processing. However, with recent technological developments, as we all know, we have multi-CPU, which are multi-core computers, which are pretty much a standard nowadays. So there are the terms like dual core, meaning 2 CPUs or 2 processors, or quad core, meaning 4 processors. And of course, the more processors or more CPUs you have in your computer, the faster the applications will work because they can basically execute these processes in parallel, right? Each CPU running one process. Another task is memory management, meaning allocating working memory, which is also called RAM, which stands for Rapid Access Memory, to different processes. Because whenever you start an application, that application needs some data so that it can work. You can't execute any program without allocating some memory to it. Now, working memory or RAM is actually limited on hardware. So if many processes are running on a computer, it may use up all the memory because each running or active process needs some memory. So what happens when you run out of memory on your computer? The operating system will handle swapping the memory between applications. It will decide that one application will become inactive by taking away the allocated memory from it, and a new one will get the memory resources. So if you have 50 applications open in total, consuming more memory than the computer's total RAM size, and you switch between them, this memory swapping will happen between the applications, and it will slow down the computer because swapping takes time. So what is memory swapping actually? In this process, operating system will unload memory, or basically clear that memory storage for that application, and then save it into a secondary memory, the storage, and load the new processes data in that cleared memory. And this clearing the data from the memory and then saving it to storage and then loading the new data to that memory location actually takes some time and slows down your laptop. So basically that process of how memory is allocated to different processes is memory management, which is again one of the most crucial tasks of an operating system. And the third main hardware component of a computer is storage, which we just mentioned, which is also called a secondary memory. So you have the working memory. This is for actively processing the data. And then you have a secondary memory or storage, which is for persisting the data long term, right? And this is the hard drive of a computer. So for example, you open Visual Studio Code and you start writing some application or some code inside. While you're actually actively working on that code, that data is loaded into a memory and is being processed as you write the code. Now, once you're done with your application and you want to close Visual Studio Code, obviously you want to save all its data and persist that on a disk for next use. But if apart from the application that you're writing and the files that you created in Visual Studio application itself has some files that need storing, right? For example, the code itself to run the application. Then you have configuration of Visual Studio, right? Maybe you configured certain plugins or themes, extensions, etc. So these are all data that need to be persisted and stored long term. So whenever you open a Visual Studio Code, you have all these configurations and plugins that you downloaded. So when you start the Visual Studio application, again, the data from the storage will be loaded in memory to use it actively. So when you open it, you have the plugins and configuration and the files in the editor just as you left it. And you can save all sorts of things on your storage. You can save files, browser configurations, games, pictures, videos, whatever. They all go to the storage. So storing this data and allocating some space for them is also managed by operating system. But note that operating system actually handles storing all this information in a structured way. So your storage is not just one big bucket where you throw all your data in. It's actually structured in a meaningful way with what we call folders or directories. In Unix-like systems, like Linux or macOS, for example, the file system is structured in a tree form. You have the root folder of the file system and you have the subdirectories. And you can build a whole hierarchy, a tree-like hierarchy of those folders and files. And then you have Windows operating system on which you have multiple root folders, but again, a hierarchical structure of folders and files also there. But we'll go through the file structure and files of Linux specifically in detail later in this module. So basically managing the storage and how data is stored is also a task of an operating system. And the last category or piece of hardware components are the I/O devices, like monitor, keyboards, mouse, trackpad, but also devices like printers or USB or external hard drive, etc. So when these are attached to the computer, operating system knows how to handle them and how to translate the interactions between the applications and these devices. And finally, some other tasks of operating system, also very important and crucial tasks, are security and networking. In terms of security, operating system is responsible for managing users and their permissions. You know that we can have multiple users on one computer, and each user will have a password so they can log into the computer and have their own space where they can install applications, save files, and do whatever they want to do. But users also have permissions. You may have an admin user on a computer that is allowed to administer it and have less privileged users who don't have that many permissions so that they don't accidentally break something on the operating system. And as I said, networking like assigning ports and IP addresses, etc. So all these are also tasks of an operating system. Now that we understand what operating system is and what its tasks are, let's see how an operating system is constructed or made up. At the core, operating system has a kernel, like a Linux kernel, for example. This is the part of an operating system that loads first when you turn on a computer. This is the heart of every operating system, responsible for managing the hardware components, again, CPU, memory, RAM. And different operating systems may have different kernels. The kernel also handles I/O devices using various device drivers. Device drivers are basically code or programs which allow external devices to interact with your computer. For example, your printer may require a device driver on your computer so that you can print from your machine. The same goes when you connect an external hard drive or USB to your computer. Kernel is the one actually bringing that external device into the computer so that you can use it. So basically, the kernel part of the operating system is the layer interacting between the applications and the hardware. So when you start the application, it's the kernel that starts the process for that application, loads it into memory, and allocates CPU resources, for example, to that application. And when you close the application, all resources will be cleaned up by the kernel. And kernel is basically just a program written in code which consists of device drivers and some other logic. And then there is the application layer on top of the kernel. For example, different distributions of Linux like Ubuntu, Linux Mint, CentOS, Debian, these are all different Linux distributions which have different application layers but are based on the same Linux kernel. So for example, they have different color theme, different icons, the graphical user interface looks different, and also they have different applications packaged inside the distribution, like different application manager, different programming languages, as well as different command line interface, compilers, etc. Another example of an operating system that is based on a Linux kernel is Android. And obviously, different from all the Linux distributions, Android is, first of all, running on mobile phones, right, on a different hardware, but also has a completely different application layer where applications and icons and everything is completely different. So as you see, Linux kernel is one of the most widely used ones because we have so many Linux distributions, plus we have Android, which is obviously very widely used operating system for mobile devices. On the other hand, macOS and iOS operating systems are based on a different kernel, which is called Darwin. Again, same kernel, but different user layer, right? Obviously, macOS, we know it's for personal computers, for laptops, and iOS is for mobile devices. Apart from the desktop operating systems, which are installed on your personal computer or laptop or a mobile device, you also have these server operating systems, right? Most of which are also based on Linux, but have much leaner application layer. So it's more lightweight and performant. For example, the server operating system distributions usually do not have a graphical user interface or other user applications like browsers or players, etc. You just have a command line interface to interact with the machine. So graphical user interface or command line interface of the application layer is used to interact with the kernel, which means kernel can't be accessible or can't be used without the operating system's user layer. So to see all the layers we have described with the Android's example, we have the hardware, which is the phone, which also has a CPU, memory, and storage, as well as I/O devices. Then you have the OS kernel on top of that, which is Linux. Then you have operating system application layer, which is Android. And then you have user applications on top of Android, like Android apps, for example. Now, of course, we know there are three main operating systems for computers, which are Linux, Windows, and macOS. And each operating system has many versions because they evolve over time and get better in terms of usability, security, performance, etc. So the kernel stays the same, but the application layer is being developed and improved. Also, as I mentioned, for Linux and Windows, we have server operating systems and desktop or client operating system distributions. So desktop or client operating systems power laptops or computers for personal use with a nice graphical user interface and I/O devices, and computers for running applications that public can access are powered by server operating systems, which usually have no graphical user interface or I/O devices. You just log into them with command line and administer computer, like install and configure things from the command line. So server operating systems are more lightweight and use the hardware resources more efficiently by running only the needed resources. Note that even though we have Windows server operating systems, over half of all the servers worldwide are using Linux as an operating system. And for macOS, note that originally it was called OS X, which later changed to macOS. So it's the same operating system with just a different name. So to summarize, basically operating system is powering all the devices like servers, laptops, phones, printers. Every device that has hardware and applications on it needs this layer to be in between. So iOS, Android are operating systems. Android is based on Linux, meaning it uses Linux kernel, while iOS, like macOS, is based on a Darwin kernel. Now, one important thing to note here is that when you work on Mac or Linux, the command line interface experience, as well as some of the file structure and how the operating system works, is pretty similar, whereas Windows is completely different from the two. Now, where does that similarity actually come from between Linux and macOS? For that, let's go back in time when Unix was created. Unix was basically a code base for many operating systems back then. And even though it sounds very similar to Linux, it was created independently from Linux, before Linux actually. And it developed in many different ways, resulting in many different flavors of operating systems that were all based on Unix, meaning they all had the source code from Unix and basically just built on top of that. And one of those operating systems was macOS. So macOS kernel Darwin, which I mentioned earlier, actually includes source code of one of the Unix-based systems, making macOS one of the most popular operating systems which came out of Unix. And because many different operating systems were developed from Unix, and there were many different versions of them, to keep them compatible with one another, standards were created for programs and applications that would run on these operating systems. So basically, this standard said that if an application is supposed to run on these operating systems, it should implement these specific APIs, it should have these functions, etc., so that you could run this application on different operating system distributions that all came from Unix. And one of the most popular standards, which we still have today, is POSIX, which stands for Portable Operating System Interface. In parallel to Unix-based operating systems being developed, Linux was created by Linus Torvalds. As I said, completely independently developed, so it doesn't have any source code of Unix. However, Linux was based on the same philosophy and concepts as Unix, which means Linux is not a version of Unix, but it's rather a clone of Unix, or also, as often referred to, it's Unix-like. So that means both Linux and macOS are today POSIX compliant, since POSIX is a group of standards that determine a portable API for Unix-like operating systems, which they both are Unix-like operating systems. And that's why there are so many similarities in the way macOS and Linux work. For example, the command line interface, how applications run on them, etc. And as you know, Linux is very popular and is the mostly used operating system for servers, but also for desktop computers among IT professionals. So knowing Linux is definitely a must for a DevOps engineer, because many DevOps tasks actually involve working with servers and installing and configuring stuff on them. Also, most of the technologies that are being developed today, including the DevOps technologies like Docker, Kubernetes, Ansible, etc., they're all Linux native technologies. Docker was originally only supported on Linux, for example. And that's why in this module, we will focus on learning Linux. And Ubuntu is the most popular Linux distribution, so we'll use Ubuntu in this tutorial, but the knowledge you gain with Ubuntu using its command line interface and interacting with it generally will be really not that different from any other Linux distributions.